Today's lesson was on function operations. I'm going to go ahead and do several examples here. I'm going to take my time doing this. So if I look at number 1, we have f, and then we have this dot, which represents multiplication. So just so you know what this is, I'm going to rewrite it. So you have f of x times g of x. And it's given to you. I'm going to go ahead and read the instructions. It says let f of x equals 2x squared plus x minus 3 and g of x equal x minus 1. Perform each function operation and then find the domain. So I have f of x, which I'm going to go ahead and put parentheses. I have 2x squared plus x minus 3 times x minus 1, okay? This will be a long process, but I'm going to take my time doing this because I want to make sure that you understand what I'm doing here. What I'm going to be doing is I'm going to be multiplying 2x squared times x, which is going to give you 2x to the third power. I have 2x squared times negative 1, which gives you negative 2x squared. Then I'm going to multiply x times x, which is going to give you x squared. And then I'm going to multiply x times negative 1, which gives you negative 1. I'm going to multiply negative 3 times x, which is going to give you minus 3. And then negative 3x. And then negative 3 times negative 1 gives you positive 3. And I'm going to go ahead and combine like terms. So I have 2x to the third power minus x squared. And of course the next term will be minus 3x, and then you have plus 2. So the product of f and g is going to be 2x cubed minus x squared minus 3x plus 2. And if I go to Desmos, you're going to see that you're going to get, you will get a sketch that looks like this, a graph that looks like this. And remember, we discussed today that the domain will be from the lowest x value, to the highest x value. In this case, it will be from negative infinity to positive infinity. So that is a domain. Negative infinity to positive infinity. Sometimes math teachers say all real numbers. So what I did here today is I went ahead and I multiplied 2x squared plus x minus 3 times x minus 1, okay? So in your homework, you have to show your steps. We're going to go on to number 2. So I'm going to go ahead and pause. We're going to go ahead and do number 2. And so I have f minus g, and then you have an x. So what this means, it's going to be f of x minus g of x. So I'm going to find, or I'm going to substitute what I know for f of x, which is going to be 2x squared plus x minus 3 minus, now you got to make sure that you have a parentheses around the function g so we can subtract correctly. So I have 2x squared plus x minus 3, then you have a minus x, so you're going to have 2x squared and let me go ahead and erase this real quick so we can draw it nice and neat. So I have 2x squared plus x minus 3, and of course we have a minus x, and then we have a minus and a negative, so that's a positive 1. So if I can combine like terms, I have 2x squared. The x and the minus x are going to cancel, and we have negative 3 plus 2, negative 3 plus 1, which gives you negative 2. And so the difference in the two functions is 2x squared minus 2. And if I were to sketch this in Desmos, or graph this in Desmos, which you will have to do on the test, you will notice that the domain is actually all real numbers. It goes from negative infinity to positive infinity, so the domain is going to be from negative infinity to positive infinity. Okay? The next part of the lesson, we have g of x equals 2x, h of x equals x squared plus 4. And then I'm going to find the values. So what I'm planning to explain to you is what we did today in our lesson. We have that circle, which doesn't mean multiplication. So this right here, I have h, and then I have this symbol, which is a circle, g of negative 5. That means composition. So that is equivalent to saying h and then parentheses g of negative 5. So let me explain what's happening. I'm going to write it in words. We will input into function h g of negative 5. So I'm going to use a highlighter. I'm going to use green. So you see what's in green, which is g of negative 5. I'm actually going to input g of negative 5. That means it's a function within a function. So in order for me to input g of negative 5, I will have to evaluate what's inside the parentheses, or whatever here is an input. So I'm going to go to function g, and I'm going to highlight it. Here's function g. They do give you the equation. So let's do that apart. Let's do that right now. So just focus your attention on the inner part, which is g of negative 5. And so I'm going to use a red marker, or I'll use a black marker so you can see it. So we're focusing on the inner part. So we're going to focus on g of negative 5. And we want to find the output. So I'm going to use the process g of x equals 2 times x. So you have 2 times x. In this case, it's negative 5. So what's 2 times negative 5? Negative 10. And guess what? This came out of g of negative 5. This is the output. So now the output, which is negative 10, will be the input for h. The output will become the input for h. And how do I see it? You just see it right here. So now I'm going to go ahead and focus my attention on the outer function, which is h. So here's the outer. And it's going to be h, function h. And you're saying, well, what is it going to take? It's going to input what was actually that came out of g of negative 5. So in this case, what came out of g of negative 5? Negative. That's right, it was negative 10. So that becomes the input for the outer function. So now you're going to focus your attention on function h, which is the one that's in blue. So you're going to focus your attention on the function that's blue. So you're going to figure out h of negative 10. In this case, it will be parentheses, because I'm using the blue function here. I'm using h. So I have negative 10 squared plus 4. So negative 10 to the second power is 100, plus 4 gives you 104. So you're saying, okay, are we done? Yes, we are. So what will be h composition of g, right? Of negative 5, what will that be? The final output was 104. Okay. We will do number 5. So number 5 is written like this. We have G, and then we have a circle, H. All this is saying is you are going to input H, function H, into G. In this case, we're going to pass a value which is O. We're going to input a value which is O. So what this statement to the left is actually saying the following. So it's G, and I'm passing in function H. And what I'm going to do is I need you to find what is the output when the input is 0 for our inner function. So step 1, you're going to look at your inner function, or your inner part of the composition, which is h of O, or h of 0. You need to evaluate that, h of 0. So go to your equations, and it says x squared plus 4. And I purposely left it open. I left it open because I'm going to input the value 0. 0 squared is 0 plus 4 gives you 4. So now I know that my output for h of 0 is 4. That's going to go into my function g. So now h of 0, what came out was 4. So now I'm going to go ahead and I'm going to input what came out of h. So it's going to be 4. So now I'm going to use function g to come up with the output when it's 4. Remember, how did I get 4? I figured out first the inner function, which is h of 0. Now I'm going to go ahead and figure out what comes out of the outer. So I have g of 4. So you're going to look at function g, and you know you have 2 times 2, and that gives you 4. So what is the solution to number 5 after we do all this? Well, g of h of 0, that composition comes out to be 4. In other words, g composition of h, that means that h goes into g, and you're going to pass in 0. So these two are the same. Okay? So the final answer, or what comes out of this composition, is 4. We're going to focus our attention on the last one. So we have G, and then we have the circle, H, and what that indicates is that the function H is going to go into G. What you're going to pass into the inner function is A. So let me rewrite this. We're going to have G, and you're passing in the inner function, which is H of A. So let's stop the video, and I want you to think, what was the difference between questions 4 and 5 and 6? That's correct. We have a variable, but we're going to do the same process. Focus your attention on the inner. Evaluate the inner. So you have h of a. So you look at function h and you look at that process, which you know it's going to be an input squared plus 4. So what is that input? A. So what comes out of h of a? What comes out is it's an expression x a squared plus 4. So where does that expression, where will it go into now? Take a second to think about where it's going to go into, and I'm giving you a hint. Yep, it's going to go into function g. So that's why in class I rewrote this, and we're still using function g. But now, instead of saying h of a, I'm going to write the expression. In this case, I have a squared plus 4. So a squared plus 4 is the input. And think about what I'm looking for. I'm looking for the output. So how do you find the output? You're going to use the function g of x. And before it gets kind of confusing here, I'm going to erase it. And I'm going to place this in the bottom. So we're looking for the outer. The answer for the outer. So you have g parentheses a squared plus 4. So you're going to go to function g. In this case, it's g of x equals 2 times x. Well, guess what? You're going to write 2 parentheses. You're waiting for that input. What is the input? A squared plus 4. So when you do the distributor property, you have 2 times a squared plus 8. And that is the composition answer. In other words, G circle H. That means G composition of H with an input of A is going to be equal to 2a squared plus 8, because that was the final output. I hope this video helped you. You might have to go back and listen to the video a couple of times. This is called composition. Remember that you are passing into a function another function. So to simplify your work, I told you evaluate the inner, get the output. The output will now become the input for the outer function, and then you evaluate, and then the final output will be your composition problem. If you have any questions, please see me after school or send me an email or text, and I will be happy to help you. Thank you.